Hi everyone, so today we're going to be doing notes on section 3.4, which is all about three variable systems of equations. So last time we looked at two variable systems, solving them using substitution and elimination. Today we're going to combine those ideas and use them to solve these three variable systems now today. So first I want to show you just a visual representation of the difference between a two variable system versus a three variable system. So when you solve a two variable system, this is when you're looking at an XY coordinate plane. Your solution is going to be a coordinate point x comma y. That's how it's written. Now with a three variable system, now you're looking at a plane. This is now three-dimensional. So you have the x and y like normal, but now you have another plane called z that goes through it this way. The little dots are to represent what goes behind it. So now it's three-dimensional, which is why our solution is going to look like this, x comma y comma z. It's going to have three variables now instead of just two. So go ahead and pause this video real quick to write down these steps. All right, so first step for solving these is to combine two equations to eliminate one variable, then combine two different equations to eliminate the same variable. In other words, this should give you a system of two equations, and that we know how to solve from our last lesson, solving systems using substitution and elimination. So our goal is to get this big, scary looking three variable system into a two variable system that we know how to solve. Once you've done that, step two is going to be solve that new system for both variables. You can do that using substitution or elimination. And then the final step is the same as before. Once you have that answer, you're going to plug those values back in to solve for your missing variable. So let's go ahead and look at an example. I'm starting the example on a new page because it's going to take up a lot of space. Now, part of that is because I'm using a lot of extra space for writing in all of the individual steps, which when you do this for homework, you are not required to write the explanation of all the steps that you're doing. But for the sake of notes, I want it to be really clear what we're doing and why. So I'm using an entire sheet of paper for this example. All right. So we are given our system. These are our three equations, and we want to solve for x, y, and z. So the first thing we want to do is eliminate the easiest variable. Eliminate the easiest variable. So I'm going to look at these equations. Now I'm going to number these 1, 2, and 3. That's equation 1, that's equation 2, that's equation 3. Just for the sake of making it easy for all of us to know which equations I'm talking about, I'm going to number them. If you wanted to do letters instead, that's fine too. All right, so the easiest variable to eliminate, if I look at this, I can see, all right, my x values, none of those have opposite coefficients. None of them are even the same number. So definitely not x. If I look at my y's, I already have 4y, negative 4y, and negative 4y. That one wouldn't be too bad. I actually wouldn't have to multiply anything. I could just eliminate y without multiplying any equation by anything. Now let's look at z's. I have two that are positive z and negative 5z. I would have to multiply at least one of the equations to get rid of z. So based on that, I've determined the letter y is going to be the easiest to get rid of because I don't have to multiply the equations by anything. I already have opposite coefficients. So I'm going to use equation 1 and equation 2. Now again, I'm just writing that to keep track of what equations I'm using where. So equation 1, I'm going to rewrite. Let me zoom this in a little bit. And rewrite equation 2. All right, now I'm going to add these together. That's going to eliminate my y. I now have a new equation. I'm going to call this equation number 4. So I've done half of step 1. I have eliminated a variable using 2 equations. But now, use 2 different equations to eliminate that same variable, to eliminate y again. So I already used 1 and 2, but I have other opposite coefficients with 1 and 3. So I'm going to use equation 1 and 3. So let's just go ahead and copy down those equations. All right, I copied down my equations 1 and 3. Now I'm going to add those together, which will eliminate my y's. And I have this new equation. So this is another new equation. I'm going to call this equation 5, just to keep track. Again, if you wanted to call these A, B, C, D, and E, that's fine. I just find it easier to label them to keep track of what I'm using. All right, so now I'm going to use equations 4 and 5 to solve for one of the variables. So let me go ahead and write them down. So I'm just going to recopy my equations. I also want to point out, I write my z with a little line through it just so it's really obvious that it's not a 2. Okay, so all I did was copy my equations 4 and 5. Now I need to decide which variable I want to get rid of. If I want to get rid of my x's, I have to multiply both equations by something. If I want to get rid of the z's, I only have to multiply the top equation. So I'm going to get rid of the z's. So I'm going to multiply this top equation by 2. Is anybody ever really bad at putting lids back on pens? I just ended up drawing green all over my finger trying to put the pen back in this cap. All right, so this is still equation 4 and 5, but now it is 2 times equation 4. So I'm going to rewrite this. It's 12x plus 4z equals 48, and equation 5 stays exactly the same. Now when I add these together, now the z's will cancel out, and I'm left with just 21x equals 84, which if I divide that, I get x equals 4. I have officially found one of my variables. Now, I need to plug in x equals 4 into equation 4 or 5 to solve for z. Doesn't matter which one, you can choose. I'm going to look at my equations and say, well, equation 4 has smaller numbers. I'm going to plug it into equation 4. So just so everyone knows which equation I'm using, I'm going to write the little 4 there and plug in my value for x. Subtract 24 from both sides, and then divide both sides by 0. I now have my value for z. I have officially solved for 2 of my 3 variables. So my final step is to plug x equals 4 and z equals 0 into equation 1, 2, or 3 to solve for y. Doesn't matter which one, you can pick. They all have their advantages for plugging in your values. So go ahead and pause this video, plug in all or those 2 values into one of your equations and solve. Push play when you're ready to check. Go ahead and check your answer. You should have gotten that y equals 2, whether you plugged it into the first equation, the second equation, or the third equation. You should have still gotten that that was your answer. So my final answer I have to write as an x, y, z coordinate point. So I'm going to go ahead and zoom this out so you can see it, see the whole page. Focus that a little bit, there we go. So my final answer, my x was 4, my y was 2, my z was 0. That is my final answer. So this is why I said I was going to use a full page for this example. Obviously, you can see that if you didn't, scoot that over so you can see all the words. If you didn't put all of this stuff in pink, all of these pink steps that I wrote out explaining what we're doing, it would take up a lot less space on your paper. Or if you did multiple columns for writing out this work, it would also take up a lot less space on your paper. I just wanted you to be able to see exactly in detail what we were doing for all of these steps for the process. So when you do the homework on your own, you don't need to put all these extra steps in pink that I wrote, but you're certainly welcome to do that if it helps you organize your thought process. All right, that is the end of your notes. Have a good rest of your day.